everyone. Thank you for attending this Digital Twin Consortium webinar, Transforming Aerospace and Defense with Digital Twins, presented by DTC member Lockheed Martin. It is my great pleasure to introduce our speaker today, Grant Epling. Grant is a senior staff project engineer at Lockheed Martin with over 25 years of project management and technical leadership experience. Today, he will give a look at how Lockheed Martin is using digital transformation and digital twins to stay ahead of ready. Over to you, Grant.
All right, thank you. Good morning, everyone. My name is Grant Epling. I'm a project engineer with Lockheed Martin Corporation. And today I'm going to talk to you a little bit about our company's digital transformation journey. I'd like to start out by saying we believe over the last few years and really the last few months, the world has been changing rapidly with alarming technological advancements and threats from various adversaries. And our customers within aerospace and defense have made it clear that they're evolving to meet the threats and that they expect us to evolve with them. So today I'm going to provide you an overview of our digital twin and digital transformation initiatives. And I'll pay particular attention to threads and twins and the various technologies that are being implemented here at Lockheed Martin. So I wanted to take a few minutes and give a high-level overview of who we are and what we do. I've attended 2 Digital Twin Consortium member meetings, and one thing that impressed me was the great diversity of different types of members of the DTC. There were urban planning digital twins, weather and solar activity twins, sustainability and conservation twins, and those are all really different from what we're working on. So it occurred to me that a lot of members might not be familiar with what we do. So I want to take a little bit of time and talk about who we are as a company, how we're transforming. I'll give you some examples of digital thread and digital twins that are being built across Lockheed Martin, and then I'll talk about what's next for us. So I would like to share a short YouTube video with you that provides what I think is a really great overview of transformation within Lockheed Martin. And as you watch the video, I want you to pay attention to 2 particular things, and we will talk about them a little bit later on in depth in the presentation. First is the description of how we're focused on creating technologies that unite disparate and complex systems, so think about digital threads. And second, the emphasis on sense, make sense, and act. So sense would be using sensors to gather real-time data. Make sense, analyzing that data so that it's intelligible and it's useful. And then finally, act, for enabling our end users to make well-informed, data-driven decisions.
Protecting what matters most is the mission that matters most. At Lockheed Martin, we know today's battlefront is behind, above, and below. So no matter where the threat comes from, we make sure you stay ahead of it. Out here, we understand that every piece of the all-domain puzzle must fit together perfectly so that you can defend our shared values and own the contested battle space. That's why we've spent decades building and connecting the platforms you need to dominate every domain across air, land, sea, space, and cyber. We've created technologies that unite disparate and complex systems so you can sense, make sense, and act, protecting in the same moment you detect. And to safeguard that advantage, we're integrating digital engineering, AI, and 5G technology into the field and within our own walls. Everything we do is in service of what you do and why you do it. Your mission is a safer, more secure world. Our promise is to help make it happen by connecting the software to the hardware to everywhere, ensuring those we serve always stay ahead of ready.
All right, I hope you enjoyed the video. I think that gives a really good overview of where we are with digital transformation and where we're headed. I won't spend a whole lot of time on this slide, but if you're not aware, Lockheed Martin is a very large company. We have 114,000, give or take, employees. We operate in 78 different countries across the world. So very, very large, very complex corporation. And Lockheed Martin also has a very diverse portfolio. We do more than just manufacture airplanes and weapon systems, which is what we're well known for. But we have other things that we do. The company is divided into 4 business areas, which we call BAs. In the upper left, you have Lockheed Martin Aeronautics. So they build the F-35, the F-22, a lot of other platforms. In the upper right is Missiles and Fire Control. We manufacture missiles, fire control sensors, But we also have work in the energy sector. Lower left, you have rotary emission systems. They manufacture helicopters, radars, undersea and surface warfare products. And in the lower right, you have the Lockheed Martin Space business area. Primary focus is manufacturing satellites, but also global communication systems and deep space exploration products such as the Orion spacecraft. So Lockheed Martin does mainly support United States Department of Defense work. And with that comes a lot of challenges, such as challenges with data compartmentalization, dealing with classified data or even unclassified data that's still very sensitive or need to know in TK. Not to mention challenges with old established ways of doing business. So you've probably heard the phrase, if it ain't broke, don't fix it. And also really just a highly risk-averse business model, which is a good thing if you were building aircraft and spacecraft and weapon systems. And the company has operated as 4 business areas for a reason historically, because we've had different product lines and different customers. But we're really prioritizing and working now to share best practices and common tools and processes and solutions across all 4 business areas to make us more efficient. Lockheed really is transforming our approach to engineering and business, but also our culture. One of my favorite quotes is from Dr. Peter Drucker, who said that culture eats strategy for breakfast. You can have the best strategy in the world, but if the culture doesn't support the change, and if leadership doesn't encourage and require employees to, embrace the change and use those new technologies and those new ways of working, the organization is not going to transform. It's not going to evolve. Okay, so having said that, this is all much easier said than done. Transformation is really a complex, highly complex endeavor. And one of our primary focuses is leveraging digital thread and digital twin technologies to unite those disparate and complex systems that we talked about earlier and that you saw in the video to enable warfighters to share information. Transformation is going to enable various assets like space, air, ground, sea, and undersea to be interconnected and share data in real time or near real time. We've also implemented Earth geotwins with really accurate weather data to enable realistic wargaming using multiple digital twins of our various platforms like airplanes, missile launchers, and ships. So why is that important? Well, simulating a combat scenario in a digital twin with high fidelity models enables leaders to see what might work, and maybe more importantly, what might not work in a contested or a combat environment, all before the warfighter goes into harm's way. So those digital twins receiving sensor data from new or legacy systems enables effective joint decision-making. And connecting those battle spaces with sensor data and feeding digital twins that real-time data brings us back to sense, make sense, and act. So using sensors to gather real-time data from the field, analyzing and making sense of all that data so it's useful and actionable, and then finally enabling digital twin users to act, to quickly make data-driven decisions. And now we come to digital twins and the components of a digital twin. Full disclosure, sometimes I try to avoid using the phrase twin because it can mean so many different things to different people. I try to focus on what problem are you trying to solve with a twin? What's the specific use case? But for discussion purposes, at Lockheed Martin, we've settled on 3 primary components for twins. Number 1 would be a virtual product or process that exists in a virtual environment. Number 2 is a physical product or process that exists or will exist, important caveat, in a physical environment. And third is the data that connects the two, connecting the virtual and the physical, also incorporating advanced analytics to make those end users able to make those intelligent predictions and decisions. So we all know that having a validated model is great. It provides you data of an object at a specific moment. But the real power of twins is that they provide you an accurate description of an object that changes over time. And as more and more data becomes available, your models, your simulations, your predictions become more accurate, they become more trustworthy, and that's going to greatly increase your customers' confidence in the value of using and continuing to fund digital twins. So as promised, I want to share with you a few Lockheed Martin digital twin use cases. And I want to emphasize also, we're focused on having visibility of a product or a process across all the different stages of a life cycle. ideally from cradle to grave. We don't want to have disconnected or siloed twins. That's the problem we're trying to solve. We want them ideally all connected to authoritative source of truth data on a digital thread as much as possible. And to help us envision that, we've come up with 7 different views, which are listed across the top of the slide. They're as designed, as built, and as maintained. So the focus here is the configuration of the pedigree of the product. Mission performance focuses on the operational performance of a product and how different configurations meet or ideally maybe exceed customer requirements and product design goals. Facility and process, so an example of that would be a simulation of a manufacturing facility to include smart machines, processes, product flow through a facility to optimize your throughput, ideally all before you cut metal and start production. Supply chain, focus on demand forecasting of parts, availability of parts, to aid manufacturing and long-term product support, and sustainment. So the focus here is on product usage data, using twins to predict how a product will perform, and that may also include prognostics to inform condition-based maintenance. Note that some twins prioritize data visibility for only one of these views. Some twins cover multiple views, which we'll see here on the next slide. So I'll talk to you a little bit about the Argus Hardware Digital Twin. It provides users visibility into engineering data in the as-built, the as-maintained config, as well as the supply chain and sustainment views per the highlighted views up top here in yellow. Argus stands for Analytic Recursive Generation Unified System. Step 1, Argus is focused on first laying the groundwork for a functioning digital thread, synchronizing and aggregating all the known data of a physical asset into one system. Argus provides you a one-stop shop approach to finding what you're looking for by aggregating data into one user interface. We aggregate data from multiple sources of truth, such as a product lifecycle management or PLM tool, and requirements databases. So the benefit of this approach is that users don't have to hunt and search through multiple tools to find what they're looking for. And the result of that is you have one tool, it's better, it's quicker access, you can get to source of truth data in one tool. It also is a tremendous cost savings for not having to pay for multiple software licenses or training users on how to use different tools. So also note that changes to the engineering baseline would occur outside of Argus. We still observe engineering change processes and configuration management. If you look down the lower right of the slide, Argus has 5 views across the different tabs of its user interface, and that allows you to interact with the digital twin data at different life cycle stages. So we have engineering, we have a sustainment view, we have a supply support view, we have a state profile view, which enables you to do high fidelity modeling and simulation, predictions and wargaming, and a simulation view, which includes augmented reality and virtual reality AR, VR experiences. So also I wanted to mention that Argus is a product agnostic digital twin. The example you see here is a missile, but any product could use Argus for digital thread, digital twin capabilities. Okay, so the second example I wanted to share with you is primarily focused on facilities. The company has dozens of industrial Internet of Things, or IIoT technologies that are enabling digital twins, from AR and VR, training, remote assistance, to drones, vibration monitoring, RFID and Bluetooth for tracking products through, for example, a manufacturing facility or a repair depot. We have predictive maintenance. We have smart buildings that I'll talk about in a minute that can detect and diagnose failures, condition-based maintenance, and also 3D scanning of objects like platforms or buildings. And the last example I want to share with you focuses on both facility and process. The goal was to embed fault detection and diagnostics, or FDD, capabilities into our facilities. I'm not going to read the entire chart to you, but I think you'll see these smart buildings have already saved the company a lot of money. There's over 4,000 connected assets, 30,000 connected sensors with 3.6 billion, give or take, data transactions per day. So using this FDD really helps us decrease facility spending and results in increased asset availability, reliability, labor efficiency, employee comfort, better predictive maintenance, increased knowledge sharing, and improved data standardization overall, which is extremely critical, as you can imagine, with digital threads and digital twins. I think this is another really good example of how Lockheed Martin is using digital twins internally to make us more efficient and cost effective. So I do want to spend a little bit of extra time on this slide to show you our digital twin maturity model, or DTMM. This model was published a year or two ago by Lockheed Martin, and it helps us have a common language with both internal and external customers. We want to use this to find out, first of all, do they indeed need a twin when they come to us with requirements or perceived requirements, or do they need something else? And if we determine that they do need a twin, we want to find out what level of maturity or technology readiness level, TRL, do they need for their twin. So this model provides all stakeholders with a common approach to digital twin design, development, and sustainment for a range of products and platforms. We also use this model to determine what type of twin a program might need, along with what level of maturity they would need based on the requirements of the customer. So at level 1, you have a standard virtual twin. This is your typical modeling and simulation setup. You have no physical asset at this point. You have high fidelity or physics-based models and simulations, and your twin will help predict mission success in compliance with customer requirements. Moving on to level 2, you have synchronization of data between the physical and the digital. The twin is representative of the physical asset, and the twin is manually synchronized with the latest design data and latest test data. Level 3, you're going to have automated or continuous data sync between the physical and the digital, as well as being able to do validations of physical assets using your twin. The twin models are going to be synchronized to the latest configuration baseline, as well as the latest design data and test data. You can also use your twin to validate physical assets. And I think here is where you're going to start to see the real synchronization and integration between virtual and physical worlds. Level 4, your integrated product twin enables highly accurate parts monitoring and demand forecasting. Your twin is going to start reducing the need for legacy physical testing. And the twin starts to serve as a master model of the product that can be used for customer validation requirements. And finally, at level 5, you have the ultimate highly connected, interconnected ecosystem of digital twins across multiple domains. Your twin models are connected, they're integrated with other products. Your end users can perform simulation-based verification without requiring physical demonstrations. And your twin may also adequately predict performance in a joint all-domain operation or JADO type environment. So we know as we implement this model across different programs, we're working to understand where each new program and where each legacy or established program is in transformation. And then we're maturing them independently with the goal that eventually we're able to integrate everyone and we'll all be using these interconnected digital twins. So the focus of transformation at this point becomes integrating all programs and all platforms to get us closer to that robust, unbroken digital thread of connected digital twins. So to wrap up, I'll go over what's next for us. Lockheed Martin is very committed to maintaining our partnerships with industry, government, and academia. Partnership with the Digital Twin Consortium has helped open our aperture, I think, to what other aerospace and defense companies are doing, but also the interesting work on twins that non-aerospace and defense companies are working on, which has been really, really great. We know collaborating across different disciplines is going to help us all find consistency and synergy with this twin development. We've always had close partnerships with the U.S. government, the Department of Defense, and NASA, but we want to expand partnerships with our allies so that we can continue to help ensure global security, or like the video said, protect what matters most. And we're also continuing to partner with academia, both in engineering and non-engineering disciplines. Another priority for us, like most other folks on the phone, I'm sure, and Digital Twin Consortium members, is to keep pushing for standards. We want to keep working together to establish a framework of interoperable, standards-based digital twin capabilities. And we think it's important to make the standards detailed enough to be useful, but not so restrictive that they're counterproductive. And we know that's kind of a delicate balance. So rather than a thou shalt do this approach, more of a you can do this or you can do that approach, depending on the use case, what you're trying to accomplish, what you're trying to solve with your twin implementation. And Lockheed Martin considers the Digital Twin Consortium's capabilities periodic table a great example of a very useful standard for digital twin development. And lastly, we want to be consistent with our digital twin development strategies across our different programs. Excuse me, we want to establish a common understanding, a common taxonomy of digital twin concepts and values, just so that there's less confusion on what twins are and what twins are not. We want to continue to implement iterative, meaningful, real-life digital twin use cases so that we can continue to close the loop between the physical and the digital worlds. And doing so is going to help us gather and report accurate return on investment, ROI type metrics to our customers. And that results in not only increasing the customer's confidence, but it helps us to continue to secure the resources that we need to continue maturing those digital twin technologies. Another key strategy for us is establishing threads that are eventually cross-discipline, cross-functional, and that's going to yield really highly connected, interesting information, concurrent digital twins. So we're interested in connecting engineering to other areas like manufacturing, business operations, information technology, security, finance, human resources. And finally, wherever possible, we want to always quote unquote bake in the hooks for digital twins as early as we possibly can in a product's lifecycle, during a request for information, request for proposal, help shape requirements and product design. I say this because we know from experience it's really difficult to reverse engineer a digital twin after the fact. So we want to really focus on automation, taking humans out of the loop wherever it's possible, using artificial intelligence and machine learning where it makes sense, and leverage new or existing APIs, and also encourage our people to move away from using disconnected desktop type tools and instead start using connected scalable tools. And that's going to enable us to continue building out a network of intact digital threads, and that enhances our broad network of digital twins that our customers are asking us to build for them. And with that, I will conclude. I really appreciate the opportunity to present to you today. It was an honor. We're committed to protecting the security of our country and our allies. It is our number one goal as a company. And as the technology that we've been talking about with digital threads and digital twins matures, we're very open to more engagements within the industry, and we're going to continue to discuss how to integrate that digital twin technology with all of our assets and all of our platforms, from land, air, sea, undersea, and even space. So we're committed to continuing to work that interoperability aspect with our vendors and our subcontractors and the government and academia and other industry leaders to ensure the success of digital twin technology.